Aryan, if at all he wants to see.
Okay, sir.
Nobody should miss the class. My duty is to provide the recording. Okay. Okay, so introducing the wave optics. So let me introduce what is light. So light comes, what do you mean by light? Basically, simple. What is meant by light? What is a light? Anybody will explain me? Generic terms. What is light?
It's a ray which travels in a straight line.
Light is an electromagnetic wave. Okay. Or you may say light is basically energy. First definition, if anybody asks you what is light, you say light is an electromagnetic wave. Clear? Anybody? Anybody asks you the first question. Okay. Or you may say light is a form of energy. Then what are the different type of light? Is the light only wave? No. Light behaves are two types. One is the photons, particle nature. Clear? Light exists as photons, not proton, photons. Okay, which is called particle nature. And one more is wave, as a EM wave. Okay. So when does it exist in photon? When does it exist in wave? Nobody has any idea. It can behave anytime. There is no specific time. No, we say no. Let's say I am a person. I work in a bank. I am a banker, and also I am a teacher. So it is not that when I am working, I am not teaching. When I am teaching, I'm not doing banking. There is a specific time. Let's say at 10 to 6, I am working as a banker. But after 6 or after 7, let's say I am working as a teacher. So my timings are fixed. I cannot be teacher between this, or neither I can do my I am not doing any my work timing during this. So but there's a specific time, but there is no specific time for light to behave. I cannot say that photons will behave Monday, Tuesday, Wednesday as photons, and Thursday, Friday, Saturday, Sunday as wave. It can behave anytime. There is no specific time. Clear? Any doubts on this?
No, sir.
No, sir.
So light, nobody is able to understand light. The moment we will be able to understand what is light, we will be able to find out what time this behaves a photon and wave. Then we will be able to crack the maximum mysteries of universe, which is not solved. There are so many mysteries of the universe which is still unsolved. Unsolved. We are humans. Remember, humans will never allow to know what is, God will never allow something which needs to be. We heard about Pushpak Viman. Have you heard about Pushpak Viman? Anybody? Have you heard about Pushpak Viman? Caroline, have you heard about Pushpak Viman?
Yes, sir.
Caroline might not heard. Caroline, have you
No,
heard?
no,
No.
sir.
So this was the because this is basically a part of Hindu culture. It is part of we are basically, if anybody has studied Ramayana, okay, Ramayana and Mahabharata are two epics of what? Of Hindu. Basically, there is no specific religion. Remember Vedas, Upanishads. These are basically not made for Hindus. It is for all. Okay, there is no specific thing that Hindus are supposed to read Vedas or Upanishads or these books. These books are available for anybody. Tomorrow, if you go and buy Ramayana, do they ask you that are you a Christian or a Hindu? No, right? They never do that. Nobody. You're not stopped. Are we stopped to go to a church? No, no. Do they not allow Hindus to go inside the church? No, right? Nothing like that. So ours is a secular country, so we allow everybody to go inside. So Ramayana, in a Ramayana, okay, basically Lord Ram, okay, when he won the Lanka, basically he killed Ravana and he took, he basically, Mother Sita was abducted. So he took back abducted to come, basically it was Sri Lanka. It was India and here it was Sri Lanka. So basically he has to go to Ayodhya, which is in UP. So he has to travel, no? That time there was no transport available. So what he did, he has to use the Pushpak Viman. This Pushpak Viman was basically, actually the owner was Kuber, Lord Kuber. Lord Kubero. Kuber is the Lord of wealth. Okay, who was the brother of Ravana. He was one of the brother of Ravana. What Ravana did? Ravana actually fought and he took his Lanka. The Lanka, basically now the Sri Lanka, his kingdom was made up of gold. Okay, so when he won over Ravana, okay, that time Vibhishana, who was the brother of Ravana, okay, became the king of Lanka after his death, after Ravana's death. So what he did, he allowed Rama, Sita, Lakshmana, Hanuman, everybody to travel using the Pushpak Viman. It was basically a kind of flight, basically a kind of aeroplane, not aeroplane. It was basically a object which will fly. You know what speed it flies? Any idea? Anybody? Siddhi? Do you know what speed it
Speed
flies?
of light.
No,
Light.
no. It travels at a speed of mind. Speed of mind.
Yes, sir. You told about it. Yes, sir.
Yes. And this speed, remember, this speed is how many times light? I also don't know. Light to come from sun to earth, it takes 8.33 minutes. How much? 8.33 minutes. Light to reach earth. Similarly, there are other planets like Pluto where light might be taking some few hours, 2 hours or something. We don't know. But your mind can go 1 lakh times faster than your mind, than this thing. So the speed of mind is humongous. You cannot imagine. So you think, and the crux how to make a Pushpak Viman, it is available in Vedas. Why did I speak light? We say that we can, if you travel in the speed of light, we can make time machine. If you travel in the speed of light, you can things get changed. The mass of the body changes. I told you. Yes or no? What is the formula? M equal to m naught 1 minus v square by c square. Do you remember this formula? You
Yes,
remember?
sir.
Okay.
Yes,
That
sir.
means if you travel the speed of light, this becomes infinite. Your mass of the body becomes infinite. So you think if the mass of the body becomes infinite, what about mind? So it is beyond our, beyond our imagination. So light is so powerful. Till now we do not have that much capability or energy to reach at the speed of light. No, we cannot. If you're able to travel the speed of light, you know how much energy will be required. Humongous. Humongous. We are not able to set up a bullet train. You know what speed the bullet train travels? 400 kilometer per hour. Yes or no? Or 800 kilometer per hour. We are not able to have that much technology in our country. Forget about reaching light. Light, we're talking about 3 lakh kilometer per second. Can you imagine the speed? Can you imagine the speed? Yeah, exactly. So light has a special place, and studying light is actually a big subject altogether. If you understand light, then we will be able to solve a lot of mysteries which the god do not want to. But it's always, we are humans. Maybe a day will come when probably we'll able to understand what is light. We're able to find out, what time does the light behaves. Any Are you clear? The just introduction. Yes.
Yes, sir.
Okay, so we will start. Basically, when you talk about wave theory, we study about a scientist called Huygens. Huygen. Huygens wave theory of light. Okay, so basically it's a very important topic which you will be studying, and this will be basically, you might get a question also. So what does it say? What does it say? Wave light wave front. Light wave front. Before that, we will study what is Newton's corpuscular theory. In 1675, what did he say? He said every light source, you can write down, every light source emits tiny corpuscles. Corpuscles. What are these corpuscles? These are elastic. What are these corpuscles? These are elastic and massless particles. Particles of different shapes and sizes. This was his theory, first point. Are you writing all?
Yes, sir.
Can you repeat? Yes, sir.
Next,
Sir, can you repeat?
every light source emits tiny corpuscles, corpuscles. What are the corpuscles? These are elastic and massless particles of different shapes and sizes.
Yes, sir.
Okay. Next point. These corpuscles, I'm writing a shortcut, travel in straight line with varying speed. That means if one light is there, it is emitting corpuscles in this direction, this direction, this direction. This may go faster, this may go slower. So each corpuscles which is emitting will be different speed in different direction. Clear? Clear?
Yes, sir.
And this theory explained what? The rectilinear propagation of light, which already we studied. Yes, in ray optics. In ray optics, we studied, no, that if you have a lens and if there is a light always travel in a ray, right? This is called rectilinear propagation. Does the light, have you seen any light which is bending like this? Does the light bend like that? Ray optics? No. So the rectilinear propagation of light was explained because of theory. This theory explained that the light always follows rectilinear straight line, and also reflection and refraction. All this was explained because of this theory. But what did this theory was unable to provide? What did the theory was unable to explain? Tell me. Who will tell me? Tell me. What is your name? Advait. What did the theory fail to explain? What was it? It failed to explain. You studied, no, wave theory? Interference,
Sir.
diffraction, and
That
what? Polarization.
the polarization.
These three basically phenomenons were not explained by Newtonian's corpusculus theory. Newton corpusculus theory did not explain interference, diffraction, and polarization. It only explained rectilinear propagation, reflection, and refraction. And these forms are the part of what? Ray optics. Yes or no? Yes or no?
Yes, sir.
Clear, right? And it was not able to explain all these three phenomena. And we will study Huygens theory. So Huygens theory came later on in 1678. Huygens, a person called Huygens, came back with his theory, and his theory was able to explain all these three. All of you clear? All of you clear?
Yes, sir.
Yes, sir.
Okay. And that was the fault. If somebody asks you, what was the faults in the Newtonian's theory? Why was the Newtonian's corpusculus theory was not able to explain all the three phenomena? You tell. It only talked about rectilinear propagation, but Huygens theory is not that. So we'll study about what is Huygens theory. Clear? Funda is clear? Okay. Now coming
Yes,
back to
Yes,
Huygens theory. What did Huygens theory say? The first is he considered light to be a mechanical wave. Mechanical wave, or what is mechanical wave? It requires a what? What? What does a mechanical wave means? It means it requires a medium.
Medium.
Medium. But you will ask question, sir. No, it is not so. The light travels from sun to earth. Is there any medium between that? No. What is there? Vacuum.
Vacuum. Vacuum.
Then how come it can travel? What
Sir,
is?
but space.
Yeah, that's what I'm coming to that. So basically, if this is earth, okay, obviously earth, outside earth, what is there? Atmosphere is there? Yes or no? And here is your sun. कौन लग रहे? ନାଇଁ ମୁଁ ତାକୁ କହିଥିଲି ପଢିବାକୁ, ମୁଁ କାଲି ନେଟ୍ ନଥିଲା, ମୁଁ ତାକୁ କହିଛି କାଲି ପଢେଇବି ବୋଲି, ତାକୁ ସେ ଦେଖିନି ଏପର୍ଯ୍ୟନ୍ତ। ମୁଁ ତାକୁ ଭିଡିଓ ଦେଇଥିଲି, 3ଟା ଭିଡିଓ ଦେଇଥିଲି ଦେଖିବାକୁ, କାରଣ ମୋ ନେଟ୍ ନଥିଲା ବୋଲି। ମୁଁ ତାକୁ କହିଲି ମୁଁ କକେଇ ମୁଁ ଟିକେ କ୍ଲାସ୍ ଅଛି, ମୁଁ ଟିକେ ପରେ କଥା ହେବି। ହଁ ଓକେ my brother here. Okay, so this is earth, and outside earth what is there? What is there? Atmosphere. Yes or no? Obviously you will have ionosphere, atmosphere has everything, ionosphere, all that is there, exosphere. So you between atmosphere and this is what? Vacuum or not?
Yes, sir.
Space is what? Vacuum. There is nothing in space, right? But you will say, sir, you are talking about mechanical wave which does not require a medium, but here light travels. So there is another hypothesis which says basically space is nothing but there is called ether. There is called ether. Ether is basically what? A dilute and a highly elastic medium which is spreading all over the space. So we are not considering space as only vacuum. Rather, we consider that there is something called ether which is actually propagating all over the space. Since ether is a medium, we are considering that it's a mechanical wave. Anybody? Any doubts? Clear?
No, sir.
So light is an electromagnetic wave. It will travel in vacuum, but to prove, because everything basically all is a theory, okay, to make sure that something is there, we have to assume. So what we are assuming, that space is nothing but ether. So there is something called ether which is actually spreading all over the space, and because ether is a medium, so we are considering it as light as a mechanical wave. Clear?
Yes, sir.
Yes, sir.
Okay. Okay. So what does the Huygens principle says? What does the Huygens principle says? First, wavefront. So if there is a light source, okay, so it will generate, if it's a point source, it will generate some kind of wavefront. It will generate wavefront in all direction. It will generate in all direction. Clear? So wavefront is the locus of all the points of the medium which are vibrating in the same space. Basically, when we say this is a point source, this will generate circular wavefront in all direction. Clear? It will generate circular wavefront, and all this are basically what? These are called what type of wavefront? Spherical. What? Spherical wavefront. Clear? So this is a point source. If you light a bulb, small bulb, it will generate in all direction. Or does the bulb generate only in particular direction? No, right? It will generate in all direction, no? All three-dimensional direction. So if you say a point source, it will generate as a sphere in all direction, and the point source will generate what type of wavefront? Spherical wavefront. Clear? Clear?
Yes, sir. Yes, sir.
Yes, sir.
Similar, like how if you remember a pond, if you drop a pebble, what will happen? Have you dropped a pebble and checked? It will generate what type of
Ripple waves will come.
circular, no? Circular ripple, no?
Yes, sir.
Does it generate half circular? No. It will generate in all direction, right? Similarly, it will generate in all direction. When you talk all direction, three-dimensional wave direction, spherically, not circular. Here we are not able to draw, but it will generate in all direction. Clear? Clear?
Yes, sir.
Next is the direction of propagation is always perpendicular to the wavefront. Means if I want to consider this direction, see this direction, if you draw a tangent, it is perpendicular. Yes or no? Yes or no?
Yes,
If
sir.
I say at this point, what is the direction? What is the direction? It is propagating. This the direction is this side. So the direction and the propagation are what? Perpendicular to each other. Clear? Yes?
Yes, sir.
Okay. So next is we understood what is spherical wavefront. Then we'll come to what is if the source is at infinite. If the source is infinite, what type of wavefront it will generate? It will generate. You remember when we considered that you have a convex lens and light is coming from sun. So what type of what type of rays will come? Parallel waves, no? Yes or no? Parallel rays, right? And they all will where? They will all will merge at where? After reflection, they all will merge at focus, correct? Yes or no?
Yes.
Similarly,
Yes, sir.
if the light source is at infinite, it will generate what wavefront? Planar wavefront. What wavefront?
Planar wavefront.
Planar wavefront. Like planes. Like basically, if I want to draw it, I'll draw like this. Clear? Clear? Okay.
Yes, sir.
Let's say if the
Yes,
light
sir.
is like a line, it is like a bulb, it is like this. Basically, you have a cylinder, you're basically a kind of, you may take some kind of wire which is actually glows. So what type of rays it generates? It will generate cylindrical wavefront. What a wavefront? Cylindrical wavefront. And what type of it is? Linear surface, linear source. Clear? Clear?
Yes, sir. Sir, I can't understand like cylindrical in wavefront, sir.
So what is
Like,
if you take a wire?
yes,
If
sir.
I take a wire, so what is wire? Wire is also like a cylinder, no? Small cylinder, right? Whose cross section is very small and the length is very big, correct? Yes or no?
Yes, sir.
So obviously when the light source is here, all the sources are here. Light source are not here, it is here. So what it will generate in all direction, it will not generate upward or downward. It will only generate which side? Like electric field, yes or no, Caroline? We studied, no? If you have a linear charge, infinite, it will only generate in cylindrical, no? Electric field will be this side, no? Yes or no? So it
Yes,
is,
sir. Yes.
so because the light source is on the what is this area
Wire.
called? Lateral area, lateral surface area.
Okay.
So the light will not come from this side, it only come from this side, all this side. So since it is like a circular, so surface is how? Circular, so it will generate in all direction, no, as a cylinder. Yes or no?
Yes, sir.
Clear? Now clear, no?
Yes, sir. Yes.
Okay. Okay. Next, write down a point. Write down a point. Every point of the wavefront, every point on the wavefront means this is a point source. This is a wavefront. Okay. Every point on the wavefront acts as a source of secondary disturbance. secondary disturbance, like these, every point on the wavefront will generate again wavefronts, secondary wavefronts. Understood?
Sir, can you repeat?
Every point, so this is the primary, this is the source. So this is the primary wavefront, correct or not? So every primary will, at every point on the wavefront, primary wavefront, will generate secondary wavefronts. Now point on this will act again as a point source. Understood? Understood?
Sir, but how can we define wavefront?
How can I define wavefront? Wavefront, what do you
Yes.
mean by wave? Wave means which is propagating, yes? What is this?
Yes.
This is a wave, right? It is traveling. It has a, what is this? Propagation, direction of propagation, yes, and this is the amplitude.
Yes.
So when you talk about wave, wave is something which travels, which doesn't stop. Okay. So like we say ripples on a pond. It will travel. It will not stay there. Yes. Have you seen? Ripple will travel and after some time the ripple will die. Correct? Yes or no?
Yes.
So what kind of wave it is? It is basically mechanical waves. Basically mechanical. That means actual what is traveling. The particles are only moving. The particles are only moving up and down. Yes or no? So similarly,
Yes,
so here wave, this is the wave and the front. What is the front side? This one. So if this is a point source, I am talking, this is the wave front, no? This is the front side of the wave, right? So front side of the wave will generate again secondary wave front. This will act as a point source again. So every point on the secondary wavefront will again generates wavefronts. They're called what? They're called secondary
wavefront.
wavelets. What they're called? Secondary wavelets. Understood?
Yes, sir.
All of you understood?
Yes, sir.
Yes, sir.
And what is their direction? What is their speed? They also will travel in the same speed of light. That means whatever speed the primary is traveling, it will travel in the same speed. It will travel in the same speed. So if I want to draw, you know how it look. Let me draw, you will come to know. Understood? That means this will also increase. Again here also. You understood how complicated it is going to be. It will be completely like an illusion. That means your prime, again this will also generate its own. Understood? Clear?
Yes, sir.
So this will keep on going in all direction. Keep on going in all direction and the speed of light. Clear? Clear, all of you?
Yes, sir.
Okay.
Yes, sir.
Next point. Common tangent on the secondary wavelets in forward direction give new wavefront. Means what? Means what? If this is my primary wavefront and this is my secondary wavefront. Yes, this is my secondary wavefront. Yes or no? He's telling the tangent at this place, tangent at this place, tangent at this place, tangent at this place, similarly tangent at this place, tangent at this place. This tangent will again give rise to one more wavefront. Clear? Clear?
Yes, sir.
Similarly, tangent at here, tangent at here, tangent at here, tangent at here. This tangent will again give rise to one more wavefront. Clear?
Sir, can you repeat the sentence?
I'm saying,
No,
This-
sir.
okay,
The
yeah,
common
yeah, a common tangent on the secondary wavelets in forward direction. Actually, I told backward direction, not in backward direction. Not, this is the backward direction. Okay. So common tangent on the secondary wavelets in the forward direction, this direction, okay, will again give rise to a new wavefront. New wavefront. Clear?
Yes, sir.
Okay. So how it will look? It will look like beautiful. Like a rangoli. Yes or no? Yes or no? It will look like a rangoli or donut kind of thing. Okay. Next point. Huygens assumed that intensity of secondary wavelength in backward direction is 0. That means if you consider the intensity of backward direction, intensity here in this direction, backward direction, is actually 0. That means there is no intensity backward direction. Intensity only is available in the forward direction. Forward direction only. Write down. Huygens assumed that intensity of the secondary wavelets in backward direction is 0. Assumption. That was his assumption.
Sir, can you say the previous point to the
Yeah, the previous point was a common tangent on the secondary wavelets in forward direction give rise to a new wavefront.
Okay, sir.
Clear? And the next point is Huygens assumed that intensity of the secondary wavelet in backward direction is 0. Clear? Clear?
Yes, sir.
I think time
Yes,
is getting
sir.
over. Time is getting over. Can you rejoin quickly, all of you? Please rejoin. Please rejoin.
Yes, sir.